Good morning.
Good morning, sir.
Good morning,
Good
sir.
morning, sir.
Good morning. Good
Good
morning.
morning, sir.
Good morning. We'll start within 2 minutes, huh? We'll wait for 2 minutes. Is it my screen is visible?
Yes, sir.
Yes, sir.
Oh, because I have shared my screen. Hmm? Okay, let us will start. Uh, we already discussed the assignment problems, and yesterday I sent you one Word file of assignment problem, right? So this Word file of assignment problem consists of the theory as well as the problems, whatever included in your syllabus, right? So theory component we already discussed, and one problem also last time we have already discussed. This is the assignment problem. Before going to solve the assignment problem, we keep in mind the given problem must be a square matrix. There are two preconditions that has to be tested. Without testing that condition, you cannot apply the solution, right? So the first condition is whether the given problem is a square matrix. Square matrix means number of rows is equal to number of columns. Second condition is if the given problem is minimization problem or maximization problem. If it is minimization problem, as it is we have to solve. If it is maximization problem, then it is to be converted into the minimization problem. Or sometimes they may not mention anything. In that case, we have to assume that by default problem is a minimization problem. Is it clear? If in the problem they are not mentioned whether it is maximization or minimization, it means that by default the given problem is a minimization problem, right? Otherwise, in the problem, if they mention the given problem is minimization problem, then as it is we have to solve. If they mention the given problem is maximization, then we have to convert to the maximization problem, and that conversion process I will tell you. If the given problem is not on a square matrix, it means that it is an unbalanced problem. Why? Because there is no balance in rows and columns, because either row is more or column is more. So whatever is less we have to add with a dummy row that I will explain orally, and we'll proceed to the next part of the assignment, transportation. Mathematical formulas, this is the definition. Whatever is displayed on screen, that is the definition. In the definition, we are going to allocating the machine to the jobs. So machine to the jobs, or it is also called a source and destinations. Source and destinations, or origins and destinations. If there are n machines, then definitely n number of problems are required. Right? So here we are going to assigning a n to n, that means one to one job, and while assigning a one job to the particular machine, the cost matrix is given. Cost is given, so that is this is called a cost matrix. C11, C12, C1J, C1N. That means if you assign a first job to the first machine, the cost will be C11, and this cost may be in terms of either money, time, or any other parameter, right? It is not like that the cost should be in rupees only. Maybe the time minimization problem is there, right? It's like this, we are going to assigning a particular machine by considering their original cost. Now, once we assign, then finally we are going to allocating the which machine, which job is assigned to which machine, and the final allocation, that is called a total minimization transportation cost. Say, as you know, the decision science always deal with minimization and maximization, that is our objective function. Any manager, it has got an objective function of minimization and maximization. Before going to solve any problem, first of all, we have to consider the objective function. So this part, the first part of the problem, in any application, in any techniques in decision science, the first part is an objective function. It is minimization. Okay, let us ignore about this mathematical formulation, right? In case if it is an offline examination, once again I will repeat this, the mathematical formulation, how it is to be derived. Okay, then subject to constraints. There are some subject to constraint. There are more subject to constraint, and subject to constraints are depend upon the variables, right? Once the problem is presented in a LPP form, right? We have to go for solving the problems, and yesterday we have already solved one problem, right? Minimization and minimization problem. Now I will explain you the unbalanced problem. What do we mean unbalanced problem? Come on, are you with me?
Yes, sir.
What do you mean by unbalanced problem?
Column and row.
You read out this problem. I'll give 1 minute. You read out this problem. Meanwhile, I have some important signature. I will do it. I will finish 1 minute. Okay. Read out the problem. Okay, now a company has 4 machines. I will explain the problem. We are not going to solve again. A company has 4 machines on which to do 3 jobs. How many machines are there? 4 machines are there. Come on, let us interaction, interactive class. How many machines are there? 4 machines are there, right? How many jobs are there? Three
Three
jobs
jobs.
Three.
are. It means immediately here we came to know that from this statement, the given problem is not a balanced problem, right? Now each job can be assigned to one and only one machine. The cost of each job on each machine is given in the following table. Yes, allocation, as in case of assignment, the allocation is 1 to 1, right? Now here, if you assign a one job to the one machine, so right, there are 3 jobs, so one machine will left blank, right? One machine will left blank. So now here in this case, we have to make it balance problem. So how to make the balance problem? Now you tell me what is less, either row or column. What is
Row.
less? Row is less.
Row.
Row is less. It means what? What is less? Job is less. What is the shortage? Job shortage is there, right? We have only 3 jobs. So one more job to be added with a dummy element, that is 0. So by default, the problem is minimization. Fine, because they have not mentioned here, right? They have not mentioned anything. So by default, problem is minimization problem. Given problem is unbalanced problem, right? Therefore, convert into balanced problem. How it is to be converted? By adding one dummy row with 0 cost. So this is the problem which we converted. Convert unbalanced into balanced problem. Now here W, these are the 4 machines and these are the 4 jobs, and the last job has got cost and 0. 0 means doesn't affect on the solution, right? Why we are adding the 0 elements? Because 0 element, if you add or subtract 0, no effect, not at all, right? So original problem is not going to be disturbed. That is why the dummy row or column is to be added. Now here, if you look at the problem, this becomes an balanced problem. So as it is, we have to apply the solution. This is the method to convert the unbalanced problem to balanced problem. Sometimes maybe the column is less. You add one dummy column, make it balance, right? Now next type of problem, one more type of problem is there, because in the examination maybe it is objective type or maybe theoretically they may ask sometimes, right? The how to convert the problem into balance one. Next type of problem is maximization problem. You read out this problem. 5 salesmen are to be assigned to 5 districts. How many districts are there? 5 districts. How many salesmen are there? 5 salesmen. Is it balanced or unbalanced? Come on.
Balance, sir.
Balance. Very good. So the problem is balance. The first constraint is over. Based on the past performance, right? Based on the past performance of salesman, the following table shows the annual sales in rupees per lakh that can be generated by each salesman in each district. Find the optimum assignment, that is maximum, right? Here word is given maximum. So now in the solution, first consider whether the given problem is balanced. Yes, it is an balanced one, right? Yes, it is balanced one. Second condition, whether given problem is minimization or no. There is no minimization word because maximization word is there. So therefore, the given problem is maximization problem. Now again, our task is to convert this maximization problem into minimization problem. And in terms of decision science, it is called and to convert the profit matrix into loss matrix, right? It is determined as to convert the profit matrix into loss matrix. Okay, now here our task is to convert this entire problem. This entire cost matrix is maximization cost matrix. So we have to convert this problem into minimization problem, and once we converted into minimization problem, as it is we have to solve. Select the smallest from each row and column, subtract, then draw the lines, count the number of lines. If lines are equal to, then you have to go for allocation. The same algorithm, same process is going to be applied. Now here, as I said, it is a maximization problem, right? So given problem is maximization problem. So this problem we have to convert into minimization problem. The conversion process is, try to understand. Conversion process is select the highest element from the cost matrix. If you look at the cost matrix, what is the highest element? If you look at the cost matrix, what is the highest?
31.
31 is the highest. From the entire cost matrix, we have to select the highest element, that is 31, and subtract the all other remaining elements from the highest element. Very easy step to convert into a minimization problem. Select the highest element and subtract all other element from that highest element. That means here the 31 minus 26, this. Again 31 minus 31, 0. Again 31 minus 15. Again 31 minus 17. Again 31 minus 20. All are getting or not? So this will be the resultant matrix. This will be the resultant matrix. All are getting or not? What I did? I subtracted all other elements from the 31 and presented in the respective location, stored in the respective location. So this is the converted problem. This is the converted problem, right? So now this is minimization problem, and as it is, we have to apply the technique. Select the minimum, bring the 0 each and every row, then again draw the lines. After drawing the lines, we have to count whether number of lines is equal to yes, it is there. Then direct we have to go for allocation and final solution. Finish. So is it clear? All types of problems I already sent to you on WhatsApp. Please download the problem and you work out these 6 problems. Nothing is more than this, theory as well as problem. This is the scope of assignment problem. Any doubts, any difficulties? Is it clear?
Yes, sir.
Notes, word notes, problems and theory notes in word format I already sent to you. Download and practice the problem whenever you get the time. Practicing the problem, it is just a game of number. It is not boring. It is very interesting, right? Whenever you get a time, you can work out on that, right? Now, similarly, similar kind of one more problem is there. That is a transportation problem that also today I will finish. So in a fresh mode, we'll start the next topic, that is linear programming problem or game theory, whatever may be. We'll see. Okay. I think there is some confusion among the students. The colleges will reopen very soon. Yes, it is under consideration. Once we receive the guideline from the government of Maharashtra, then definitely we will think to open a college on physical mode. What is your opinion? Do you want physical mode or online mode?
Online, sir.
Good.
Online, sir.
Sir, physical.
Online,
Mhm.
physical mode, sir.
Some are saying physical, some are saying online. Okay, we'll say, I think in Pune, except schools, they have started except Pune and Aurangabad, right? So what decision they will take about the colleges in Pune region, that I don't know, right? But we'll follow the government guidelines, right? And those who are not possible due to some reason, some genuine reason, you don't worry. I have an online sessions also, right? Because last time I taught completely with very systematic, and entire sessions I recorded. So I will send you that sessions, recorded sessions. You listen at home. If you have any queries, you can contact me anytime. Same notes. This is the last time prepared notes in Word file, as well as the videos are also there. I will run one sample video so that you'll understand the same thing, same concept, right? Okay, now I'll go for the. Shall I move to the transportation? Shall I move to the transportation? Because
Yes, sir.
this time examination again, the Minister of Higher Education, Sawant Sahab, he made a statement the examination will be online, but we have to make it we have to be ready for the online as well as offline, right? We have to be ready for online or as well as offline. If it is offline, you don't worry. Only I will concentrate on problem, and 3 to 4 days the entire problem only will discuss. You need not worry about it because in the examination simply they ask the problem, but online instead of problem the concept, theory concept, and that I already told you. Without the understanding problem, you cannot understand theory. Okay, now so I'll move to the transportation problem without wasting a time, right? Yesterday, last lecture, I think I already highlighted what is transportation problem. Transportation problem, again the same thing. Transportation problem deals with the transporting the goods from one location to the another location. I was quoted one example, that is the factory and warehouse. Factories are located somewhere else, one place. Warehouses are located another place. There are suppose 5 warehouses and 3 factories. There are suppose 5 warehouses and 3 factories, right? So again, the 5 warehouses may not be located at the same location, isn't it? The 5 warehouses may be located at different location. So all warehouses, permutation combination, all warehouses are located at different locations, and all factories also located at different location. If it is located in the same location, there is no question of transportation problem, right? But the practical situation or scenario is, we are assuming the scenario is the factories and all warehouses are located at different locations. Maybe the distance is in 100 kilometers, 200 kilometers, 500 kilometers, or whatever maybe. But our assumption is the factories and warehouses are located at different locations. Now, if you want to transport the goods, right? Say as a manager in a supply chain manager, if you are playing a role of a supply chain manager, right? Now, in this case, how you are going to supply the goods to the factory, or again, how you are going to shifting the finished goods from a factory to the warehouse, because we never transport our goods directly from factory to the customer door. It has to be dumped somewhere else. It has to be stored in a warehouses, right? And then only the goods is going to be sent to the market. It is not the situation. It is not the case. In a very few product it is applicable, right? Okay, now here in this case, if you want to transport the raw material from a warehouse to the factory, or if you want to transport the goods, that is finished goods from a factory to the warehouses, right? Then the first of all, we have to consider what is the capacity of a factory. Only that much goods we can transport to the factory. Excess good cannot be transported. Similarly, whenever you transport the finished goods from a factory to the warehouse, right? Again, we have to consider the capacity of a warehouse. We cannot transport the finished goods over and above of an a capacity of warehouse. Now I'm audible. Am I audible?
Yes, sir.
Because some
Yes,
technical
sir.
some technical issue was there. Okay, what was the last point? I'll share the screen. What was the last point? Transportation problem. We were discussing the transportation problem. Am I right? Yes or no?
Yes, sir. Yes, sir.
Okay.
Yes.
Yes,
What was the
sir.
last statement? What was my last statement? Hmm? Anyone? You are not logically present. You just physically you are present. Yes, Pooja. What was my last statement? Okay, transporting the goods. Come on. Are you with me? Yes or no?
Yes, sir.
Yes.
Yes, sir.
Okay, transporting the goods from factories to the warehouses. Now, in that case, we need to find out what is the requirement of factory. Only that much goods to be transported, right? As a manager, you should not transport the extra material. Again, same thing. Whenever you transport the finished goods of a factory to the warehouse, whatever capacity of warehouse, you cannot again transport the excess goods to the warehouse, right? Now this is the transportation problem. This is assignment. Okay, now I'll open the transportation problem, right? Transportation. See, sample video I will run. Sample video I will run. Okay, just sample recorded session I shown, right? But today I will discuss just revision of transportation problem. So, okay, so this is the word file. Today I will send you the word file of transportation problem. The definition, there are m number of origins, that is I from 1 to m, and n number of destinations. As I said, the origin means, say for example, factories, and destination means, say for example, warehouses, right? To transport the goods from a factory to the destination, origin to the destination, or factory to the warehouses. So what is the transportation cost? So this is the transportation cost. C11 means to transport the goods of first origin to the first destination, transporting the goods of first origin to the second destination, so on, transporting the goods of first origin to the zth destination, so on, transporting the goods of first origin to the nth destination. But whenever you transport the goods from a origin to the destinations, what is the capacity of this origin? What is the capacity of origin? This is the capacity. This indicates the capacity, because as I said, the capacity and requirement is very important. How much capacity, that much goods we are going to transporting. How much requirement, that much goods we are going to transporting. That means that depend upon the capacity and requirement, the goods are going to be transported, right? Okay, now here the condition is, the very important condition is in transportation problem, try to understand the MCQ type of questions. Always in case of transportation problem, there should be a equal number of requirement and capacity. That means here summation of AI is equal to summation of Bj. Means whatever requirement, only that much capacity has to be there, or whatever capacity, that much requirement has to be there. Right? Exactly. Whatever the requirement of a warehouse, only that much material we can shift. What is the capacity of factory? Only that much material we are going to shifting, transporting. So here in case of transportation, always keep in mind the number of requirement, summation of requirement is equal to summation of capacity. That is summation of AI is equal to summation of Bj. It is always there. If it is not equal, then it is called an unbalanced problem. I will explain that. Mathematical formulation. Again, same thing, as I said, in case of transportation, objective function and subjective constraints, right? Objective maximization or minimization and subjective constraints, there are n number of subjective constraints, because how many variables, that many subjective constraints are there. Okay, let us keep it aside. Now, the methods of finding the transportation problem. We can find the transportation problem. We can solve the transportation problem by using three different methods. The first method is called a northwest corner rule method, right? Second method is lowest cost entry method, or it is also called a matrix minima method, right? Also it is called a matrix minima method. And third method is a Vogel's approximation method. What is called the Vogel's approximation method, or it is also called a penalty method, right? Penalty method. And whatever solution we are getting by using these three methods, whether it is an optimal or not, the best solution. What is my optimal solution? The best solution. Whether the solution is the best solution or not, that can be tested by using a modified method solution. It is called a Modi method. So these three methods today practically, with the help of problem, I will discuss, and then immediately we'll move to the next topic. Now the northwest corner rule method, before going to solve the problem, before going to apply these three methods, keep in mind, otherwise you note down somewhere else. Northwest corner rule and lowest cost entry methods, they gives the basic feasible solution. Note down somewhere else. Basic feasible solution, or it is also called an initial solution, or it is also called an initial basic feasible solution. Mostly in MCQ question papers, they may ask, right? The northwest corner rule gives the different which kind of solution. So northwest corner rule and lowest cost entry method, first two methods, they gives the initial basic feasible solution, or it is also called a basic feasible solution, or it is also called a feasible solution. Meaning will remain same. The different way they are using word, either feasible solution or basic feasible solution or initial basic feasible solution. But keep in mind, the first two method always gives, once again I am repeating, are you with me? Once again I am repeating. Come on.
Yes.
Yes,
So first two method, which first two methods? The northwest corner rule method and lowest cost entry method. First two methods, they gives the basic feasible solution. Also it is called initial basic feasible solution. Also someone can say a feasible solution only, right? Now What do you mean by this solution? So this solution is not an optimal solution. What is my word? This solution is not an optimal solution. It means what? This solution is not the best solution. What is optimal solution? The best solution means it is an optimal solution. So initial basic feasible solution is not the best solution. Still there is a scope for improvement. Note down, right? The first two methods, they not gives the optimal solution, best solution, right? I cannot say that it is worst solution, but it is not the best solution, but still there is an improvement. Still we have a better solution than this, right? Is it clear? So the first two methods, they are not giving the optimal solution. They are not giving the best solution, right? Best solution can be decided by using a Vogel's approximation method. So now the next point is very important. Vogel's approximation method gives an optimal solution. All right. Vogel's approximation method gives an optimal solution. That means the best solution. So keep in mind, whatever solution we are getting by using a VAM method is always better solution than the first two methods. What is my statement? Keep in mind, whatever solution we are getting by using the VAM method, right, is always better than the first two method. That is why I am saying that the Vogel's approximation method gives an optimal solution or a best solution. I am not using the correct 100% correct solution. I am using the best solution. Best solution can be improved. Best solution can be improved. Am I right? Yes or no? The best solution. Yes. Okay. I'm saying the best solution, but the best solution can be improved, right? That means again there is a scope for the improvement in a optimal solution also. Means whatever solution we are getting by using the VAM method, that is called an optimal solution. It can be improved. It can be improved, and whether it can be improved or not, whether it is an optimal or not, that can be tested by using a MODI method, modified solution method. That's one. Finished. This is the concept of an northwest curve. Now, very fast, you note down this problem. Chalo, we'll work out one by one. Note down the problem. Problem number 1. Find the initial basic feasible solution of the following transportation problem: warehouse and factory. Note down this problem. Come on. Is it my screen is visible, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Fine. Note down the problem. Note down the problem and don't lose the patience. Right? Carefully you try to understand. If you're not understanding immediately, you can interrupt me. Because this is not an offline mode, right? Your concentration is required. And don't lose the patience. Huh? It is very simple. The solution is very, very simple. Not much knowledge of mathematics is required. Only addition, subtraction, multiplication and division is enough. In decision science, though it is called a mathematical oriented paper, no mathematical knowledge is required. Very basic knowledge of mathematics is required. Once it is over, you tell me. Huh? Same problem will work out by using 3 different methods so that you will understand the difference between the methods. Same problem will work out today by using a different methods.
Done, sir.
Good. So I will read out the problem. I will read out the problem. Now, first method is northwest corner rule method. Write down the method's name also at the top. First method is northwest corner rule method, and the problem is find the initial basic feasible solution. What is the word? Find the initial basic feasible solution of the following transportation problem. Now here they are already asking to find the initial basic feasible solution. That means you have a scope to apply either first or two method. Applicability of the method is very important. Unnecessary, don't apply the complicated method. Here they are expecting only northwest corner rule or lowest cost entry method. First two methods they are expecting. So don't go for the penalty method. Penalty method is somewhat difficult than the first two method. So read the carefully problem, find the initial basic feasible solution. It means that any one method can be applied either first or second, northwest corner rule or lowest cost entry method. In case if they use the word find the optimum solution for the following transportation problem. Suppose what I'm saying that in case if they ask find the optimum solution instead of basic feasible solution, optimum solution, then which method is applicable? Come on. Yes, come on, please. If they are using to find the optimal solution, then which method is applicable? Third method, Vogel's approximation method. Just now I said Vogel's approximation method gives an optimal solution, right? So if the word is optimum, then the optimal solution method is used. Now here, fine. So first two methods we have to apply. Now problem is factories and warehouses. How many factories are there? 3 factories are there. How many warehouses are there? 4 warehouses are there. In case of assignment problem, immediately the question came into the mind, no, it is not balance problem, but no, the case is not applicable in transportation problem. In transportation problem, there may be a unequal number of rows and columns, accepted, allowed. Only the thing is whatever the capacity and requirement, right? Whatever the capacity and requirement, the summation of capacity and requirement must match. I will explain first problem. The factory 1. If I would like to transport the goods from factory 1 to the warehouse 1, the transportation cost is 19. Maybe the 19 minutes or 19 hours or 19 days or 19 years, whatever may be. Right? So from factory 1 to warehouse 1, 19. Say for example, if it is in hours, I will use the hours. Or minutes, 19 minutes. If it is minutes, I will use minutes. I will assume minutes. Factory 1 to warehouse 1, 19 minutes are required. Factory 1 to warehouse 2, 30 minutes are required. Factory 1 to 50, warehouse 3, 50 minutes are required. Like that, the 10 minutes are required to transport the goods from factory 1 to warehouse 4. But how much production of F1? Maximum 7 production is allowed. This may be in tons or kg or whatever may be there, right? Capacity in maybe in tons, maybe in kg, in 1000 kg, right? Okay. Similarly, if I would like to transport the goods from factory 2 to warehouse 1, the 70 minutes are required. Similarly, 30 minutes are required for warehouse 3, 40 minutes are required for warehouse 4, 60 minutes are required, and the capacity of this F2 is how much? 9 tons. Similarly, F3 factory to warehouse 1, 40 minutes, 8 minutes, 70 minutes and 20 minutes are required. But what is the capacity of F3 factory is 18 tons. So this is the capacity of a factory. But whenever you shift the goods from a factory to the warehouse, what is the availability? What is the scope? How much space is available in warehouse? So here I can store 5 tons of material in warehouse 1. Here I can store 8 tons of material in warehouse 2. Here I can store 7 tons of material in warehouse 3. Here I can store 14 tons of material in warehouse 4. Only the manager is concerned about how much goods is produced, only that much goods to be stored in a warehouse, or how much raw material is available in warehouse, only that much material is to be supplied to the factory. right? Now here first constraint, right? First constraint is summation of capacity, sum or total. What is the first constraint? Here I will write down first constraint A. Total of capacity is equal to total of requirement. Now keep in mind, are you with me? Yes or
Yes,
no?
sir.
Yes, sir.
Yes, sir.
Okay. Now very important, very important. Whatever I'm highlighting, is it visible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now I highlighted. Now what I highlighted now, I highlighted only the cost matrix. Actually, the cost matrix is this, and capacity and requirement is not the part of a cost matrix. Don't make confusion while solution. This is very important, right? The capacity and requirement is not the part of a cost matrix, right? Not the part of the cost matrix. So this is only the cost matrix. That means the transportation cost is given in these cells, right? Okay. Now here the first constraint, like an assignment problem in transportation problem, has to be considered whether total of capacity is equal to total of requirement. Come on, work out total. Come on, work out total. What is the total of capacity?
34.
7, exactly right. 7 plus, practically I will write here, so you'll understand, everyone will understand. 7 plus 9 plus 18. Am I
18.
right? Is equal to, come on,
34.
5 plus 8 plus 7 plus 14. So this is how much? 34 is equal to how much?
34.
34. So the first condition is satisfied. First condition is satisfied. This, before going to apply the solution, first of all we have to check whether the summation of capacity is equal to summation of requirement. If it is equal, then it is called a balanced problem. If it is not equal, then it is called an, what kind of problem? Tell me.
Unbalanced problem.
Very good. Unbalanced problem. It is called an unbalanced problem. Okay, now for example, I will change. This is 10, right? This is 10, right? And summation of this is how much?
30.
Right? Now, is it equal? 34 is equal to 30. Is it equal?
No.
No.
No, sir.
Now it is called a unbalanced problem. So if the problem is unbalanced problem, then our role is to convert into balanced problem. Now how you will convert? Just you can you think how you will convert? Think how we will convert. We have to make it balance. We have to make it balance. So in case whenever you want to make it balance, in that case, what is shortage? First of all, we are checking. What is shortage? Requirement is shortage. Are you getting or not?
Yes, sir.
Yes, sir.
What is shortage? Requirement is shortage, right? Okay, requirement is shortage. If you want to, how much shortage is there? How much shortage is there? 4 shortage. 4 shortage.
4
is there,
shortage.
right? 4 shortage is there. How much shortage is there? Requirement is short. How much it is short? 4 it is short. So it should be added in a requirement. If it is added in a requirement, then what I should insert? I should insert row or column.
Row.
Come on, come on. What I should
Column,
insert?
dummy row.
Column, dummy column, right? Dummy column I should insert, right? So here insert the column, right? Dummy column should be inserted, and this is W5. And what is the cost matrix of this? 0, 0, 0. And what is shortage? 4 is shortage.
4.
4.
Have you understand?
Yes, sir.
All are with me.
Yes, sir.
All are with me.
Yes, sir.
Hmm?
Yes,
Okay.
sir.
Now if you count this summation, 5 plus 8 plus 7 plus 10 plus 4 is 34
34.
is equal to 34. Is it clear? Now,
Yes, sir.
Yes, sir.
oh, yes. Okay. Right. Now, fine. Now suppose here it is n. Come on. Hmm? What is the total?
26.
26 is the total. 26 is the total. Now 26 is equal to 34. Am I right? Again, is it a balanced one now? No, it is not balanced. Right?
No balance.
Right? It is unbalanced problem. Now how you convert it? Now what is less? Capacity is less. What is less? Capacity is less. So we have to add capacity here, right? We have to add capacity. If you have to add capacity, please unmount. Here, please mount yourself. Right? Okay. Now what is to be added here? What is to be added? How to make it balance? Row should be added, right? So row should be added. So here we have to insert the row, right? And F4 cost is 0, 0, 0, 0, and what is the shortage?
8.
8 is the shortage.
8.
All are getting or not? Both way I explain. Whatever is less, we have to add. Either column is less, we have to add column. If row is less, we have to add row. But the both total must be equal, otherwise it is called an unbalanced problem. So this is what the first and the precondition before going to solve the transportation problem. If the given problem is unbalanced problem, and if you start applying the methods, your problem will be wrong, right? You'll get 0 marks, right? Or in case of MCQ type questions, sometimes they may ask you how to convert the balance to imbalance problem, maybe with small example. Okay, fine. Now, shall I move to proceed? Shall I move to next
Yes, sir.
step? Okay,
Yes, sir.
now here, notation wise, I have mentioned here summation of AI is equal to summation of BJ. Summation of AI means requirement total is equal to summation of BJ means what? The capacity total, right? This is called summation of AI and summation of BJ. If it is equal to the given problem is balance the problem. Fine. Given problem is balance problem. Chalo. Now you do one thing. You know, just draw the blank table of this factory 3, 4. Draw the blank table. Come on. Draw the blank table like me. Come on, fast. Do fast. Oh my color.
Done, sir.
Okay, wait. Huh?
Done, sir.
Mhm. I would like to remove my original color. Hmm? No, yes, I selected here. Wait for 5 minutes. Yes, right. Selected. Yes, okay. So I selected. Yes, select. No, selected this. Right click. Smaller.
Second.
Below A. How? This one. This one. Oh, right. Okay. Right. Fine. Thanks. Hmm. Okay. Now, chalo. Let us start solution.
Yes, sir.
Yes, sir.
Don't worry. Next lecture, I'm going to continue. That is why I have taken 2 lectures. Very slow, very systematic. We'll finish this because it is in online mode. And if I discuss these 3 problems, you can attempt the all remaining problems on your own without facing any difficulty. So the next lecture also I'm going to continue. You don't worry about that. Right? Okay, chalo. Now, first method, which method we are applying? Northwest corner rule method. All are ready with this? Chalo, come on,
Yes,
fast now. We'll apply.
Yes, sir.
Okay, the first corner we have to select. This corner we have to select. Right? After selecting this corner, I'll write down here 19. Again here, text color we have to change. Okay, right, 19. Come on, write down the cell, copy. 30, 50,
50,
10,
10,
matrix, fill the matrix first. 70,
70,
30,
30,
40, 60, 30, 40,
40,
60.
60,
Next, last cell,
40,
48, 8, and
70,
70. Hmm. And
20.
20. Right? Now, what is the capacity? Capacity is 7. This is 9. Right? 7. 7, 9, and 18. Right? Seven, 9, and 18. Okay, next 5, 8, 7, and 14. Fine, chalo. Will work out. Chalo, first corner we have to select here, right? We have to select the first corner, right? After selecting the first corner, are you ready with? All are ready?
Yes, sir.
Come on,
Yes, sir.
come on. Now, very important steps I'm performing. All of you with me? Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Select the first row, that is first element, 19, and here we have to allocate. How much to be allocated? Come on. How much to be allocated? Come on. What is to be allocated now here? Here we have to allocate now either capacity or requirement. How much is to be allocated now? Capacity is 7 and requirement is 5. How much I can allocate here?
5.
Yes, sir.
5.
Requirement.
Requirement 5 I can allocate. Why 5 I can allocate? Because I cannot allocate or I cannot store the goods more than the 5 tons in warehouse 1. That is block. So if I allocate this 5, right? So what was the capacity of warehouse 1? 5 capacity was there. So all these 5 capacities are allocated. So this is completely block. Am I right? This is completely block. So here I can use the different color. Okay, I can use this different color, right? All are getting
Yes,
or
sir.
not?
Yes, sir.
I allocated 5 because only this warehouse has got an capacity 5. So this 5 entire 5 is over. Entire 5 is over. So I'll put the dash here. I'll put the dash. Right? I'll cross out this. Out of 7, how much is allocated? See, the meaning of the logically meaning of this is factory 1 is having a 7 tons capacity. Out of 7 tons capacity, how much tons we allocated here? 5 tons we allocated. So how
5.
much tons are remain? How much still it is
2.
remain? 2.
2.
How much it is remain? 2. So here new allocated value is 2. New allocated value is 2. Right? So this is 2. Now this is completely blocked. I cannot reallocate in this particular column. So I should move to the next row, next column, right? And here again, I can allocate. How much I can allocate now here? Capacity is 2 and requirement is 8. How much to be allocated? Come on, 2 I can allocate. Okay, so now the capacity 2 means the factory 1 capacity is completely fulfilled. Factory 1 capacity is completely fulfilled. Nothing is left, right? All 7 tons is allocated. So this is completely fulfilled. So I can block this, right? I can block this. You can just cross. Okay, I can block this. But out of 8, how much tons we allocated to warehouse 2? Warehouse 2 capacity is 8. But out of that, how much we allocated there?
2.
2 is allocated. How much is remain? Still, how much space
6.
is remain? 6 tons of material. Still, I can store in this warehouse, right? 6, right? Okay. You have to cross 8 and new value we have to add to the next. Okay, chalo, next. Finish. Is it clear? Now, factory 1 is completely blocked. I cannot move to the next cell. I have to come down. So I will come down to this, right? You keep on moving either next or down cell. So next cell is completely blocked. So I don't have option to move to the next cell. So I have to come down to the next row, and next row here again I shall allocate. How much? Requirement is 6 and capacity is 9. So I can allocate here 6, right? Okay, I will allocate 6. Out of 6, 6 is completely allocated. 6 plus 2, warehouse 2 requirement is fulfilled, right? Warehouse 2 requirement is already fulfilled. Similarly here out of 9, right? Out of 9, How much is allocated there?
6 allocated.
Hmm?
6.
Out of 6 is allocated, right? Okay.
Yes,
So
sir.
how much is remain? How much is remain? 3 is remain.
3.
3.
3 is remain, right? Okay. So I will cross out this and 3 is remain. Now here, what is completely blocked? The warehouse 2 is completely blocked. So this I can change the color. I cannot proceed to next, right? Okay. Okay, fine. Now, next. I can move to next, this cell, right? Okay, now here, how much I can allocate again? Here
3.
again, how much I can allocate? 3 I can allocate,
3.
right? So if I allocate 3, 3 has gone, right? That means it is completely allocated. And out of 7, 3 is allocated. So how much is remain?
4.
4
4.
is remain, right? 4 is remain, right? So this is 4 is remain. Right? Next. Now, what is completely blocked now? Factory 2 is completely blocked. This is completely blocked because 6 plus 3 is already allocated, right? Okay. Now, where I should move? I have to come down to next,
Factory 3.
right? Factory 3. So this is completely blocked. So I can change the color, this color, right? Okay. Not visible, no? Okay. Now I should come. You do one thing. You just cross lines. Okay. Now here, factory 2 is completely blocked, right? And factory 3, this I can move now here. How much I can allocate here now? This is
4.
18 and this is 4. So I can allocate 4. I can allocate whichever is less. Just we have to allocate. So this has gone. Right, the 4 is allocated, and out of 18, how much is allocated? Out of 18, the 4 is allocated. So how much is remain? How much is remain here?
14.
14 is
14.
remain, right? 14 is remaining, right? So 14 is remaining. Now only one cell is left, right? Only one cell is left here. So I can allocate, but in this case, 100%. Whatever is left, capacity and requirement is matching. That means, see, the capacity is 14 and requirement is 14. It means that both are fulfilled and our answer is correct, right? Because both are telling. It has to. Why it has to? Because the summation of EI is equal to summation of BJ. That is why whatever is last cell remaining is should be match. Now we have to find out the total cost. The total cost is equal to 19 multiplies of 5 plus 30 multiplies are 2 plus 30 multiplies are 6 plus 40 multiplies are 3 plus 40 multiplies are 3 plus 70 multiplies are 4 plus 20 multiplies are 14 is equal to 105. This is what the total transportation cost, right? This is what the total transportation cost if I apply this technique to transporting the goods from a factory to the warehouse or warehouse to the factory. So this much cost will be incurred. So this much cost will be incurred. Either this cost is in rupees or time, as I already said, right? So this is the very simple northwest corner rule method. Now the same problem will work out by using the uh, next method, that is the lowest cost entry method, right? Next method is the lowest cost entry method. Come on, note down. Lowest cost entry method. lowest cost entry method, or it is called it is also called a matrix minima method. Matrix minima method. Okay, now copy the matrix as it is. Come on, fast. This problem you have to copy as it is. Copy as it is the problem. So this is the problem, warehouse and factory. Yes, or have you copied?
Yes.
Second method,
Yes, sir.
second method, lowest cost entry method, matrix minimum method. Copy as it is the problem and we'll find out the solution. Right? Solution. So here only I will write the solution. Solution. Come on. In a solution, again the same condition we have to test. What is whether summation of AI is equal to sum of, it is already there, solution. Chalo, we'll work out. Same first constraint. What is first constraint? The summation of AI is equal to summation of Bj. Yes, it is there because the same problem we are going to continuing, right? It is not a balanced one, unbalanced one. It is a balanced problem. Now we'll start the solution. Are you with me? Shall I start or wait?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now, lowest cost entry method or matrix minimum method, name itself suggests that whatever the element, whatever the smallest element from the cost matrix, we have to select, which is the lowest cost from the cost matrix. We have to select. As I said, the cost matrix only this much. Cost matrix is only this much, right? Lowest cost. This is the cost matrix. Capacity and requirement is not the part of the cost matrix. Don't confuse. Capacity and requirement is not the part of a cost matrix. Don't be confused, right? Now here, what is the lowest cost among this matrix? What is the lowest cost among this matrix? 8. Are you getting or not? 8 is the lowest cost. So I will select this element and here I have to allocate. How much I shall allocate here? How much? 8 I shall allocate, right? Why 8? Because the warehouse to capacity is only 8 ton, so only 8 ton I can allocate. Now what is completely block? What is completely block? Warehouse 2 is complete. Warehouse 2 is block. And what is, how much is remain? Capacity of F3 is 18. Out of 18, 8 is allocated. So how much is remain? 10.
10.
Am I right? Okay, so here how much is remaining? 10 is remaining, right? 10 is remaining. 10. Now this is completely blocked, so I'll make a different color. Like this I will use. Okay. This way I can use. Okay. Now, is it clear up to this? All are with me?
Yes, sir.
Yes, sir.
What I did, I
Yes,
selected the minimum. I selected the minimum element from the entire cost matrix. And again, I'm repeating, capacity and requirement is not the part of a cost matrix. Say from the cost matrix only, I selected the minimum, first minimum, and allocated whichever is less. Sorry, allocated whichever is less, either requirement or capacity. So here, this is less, so this is allocated here. Okay, finish. Now this is block. Now second time, again the same logic we have to apply, right? Same logic we have to apply, but second time whatever is allocated, don't consider this column, right? Don't consider this column. So from remaining element, what is the remaining element? That is 19, 70, 40, 50, 10, 40, 60, 17, 20. What is minimum?
10.
10 is minimum, right? So here we have to allocate. How much I shall allocate here? Again, 7. Whichever is less. Logic is whichever is less. Okay, 7 is allocated. So this is completely block, right? This is completely block. And now here the 14, out of 14, 7 is already allocated. So how much is remaining? 7 is remaining, right? How much is remaining? 7 is remaining. So next time we have to allocate this 7. Sorry, yeah, 7 is remaining, right? Okay, what is block? This is completely block. So now this is block. Am I right? This is also block. Okay, now what is remaining now? Come on. What is the lowest element remaining? 70,
20.
40, 40, 70, 60 and 20, 20,
20.
20. How much I shall allocate here now?
7.
7.
7. Right. I can allocate here 7. Right. Okay. So again, the 7, this is completely allocated. Out of 10, how much is allocated there? 7. So how much is remaining here? 3.
3.
Right. How much is remaining? 3. Okay. Now this is completely block, right? So I'll use the color, different color. Chalo, next. What is the smallest element from remaining? 40. But how many 40s are there? How many 40s
Two.
are there?
2.
4 40. Two 40s are there. So arbitrary any 40, any one can be selected. There is no hard and fast rule. Anyone can be selected, right? Come on, tell me which one. If someone select the first 40 and some students select the another 40, the answer may vary. Huh? Answer may vary, and don't worry. In case of assignment and transportation, the answer may vary a person to person. Right? In such cases, in such situations, sometimes the answer is vary. Okay. Now tell me which one. First one.
F3.
F3. Okay, fine. Chalo. Now how much I can allocate here? 3.
3.
Am I right? How much I can allocate? 3.
3.
Why? Because this 3 is small, this is 5. So 3 is allocated. Fine. Now, once 3 is allocated, this is completely block. This is completely block, right? This is completely block. Okay. Now, how much elements are remain now? Remaining elements are 40 and 70.
40 and 70.
40 and 70. So now here, in case of 40, again, I will go for allocation. How much I can allocate here?
7.
7 I can allocate, right? How much I can allocate? 7 I can allocate. Okay, so if I allocate 7 here, how much is remain here now? 2.
2.
This is remain how much? 2. I will cross out this, and here remaining element is 2. Here also 3 is already allocated, right? So I will cross out this, and here how much elements are remaining?
2.
2. 2. Okay, now what is block now? Right? What is block? Nothing is block, right? Because here 7 allocated, here 7 is allocated, 2 is remaining, right? 2 is remaining. So what else is remain now? Only one cell is remain, this 70. So how much I can allocate here now? Come on.
2.
2. Only 2 is left. So 2 is allocated. So now once the allocation is over, say at end capacity is 2 and requirement is 2. It means our answer is correct. Now here we have to find out the solution. What is solution? Total cost, total transportation cost. Total transportation cost is, come on, tell me, 70 multiplies a 2, am I right? Plus 40 multiplies a 3, allocation only we have to consider, plus 40 multiplies a 7, plus 8 multiplies a 8, next 40 is over, 10 multiplies 7, 20 multiplies a 7. What is the total cost? Work out. What is the total cost? What is the total cost? Are you with me?
Yes, sir.
Chalo, work out the total cost. Allocated sales 70 multiplies are 2, 40 multiplies are 3, plus 8 multiplies are 8, plus 40 multiplies are 7, plus 7 multiplies are 7. Sorry, 10 multiplies are 7, plus 20 multiplies are 7. Am I right? I have noted right now. How much cost?
814. 814.
814. Right? Okay. Now this is the transporting the cost from a warehouse to the factory and factory to the warehouse by using the second method. Now the first method answer is 105 transportation cost. What was the cost in first method? It was 115. Sorry, 1015. Right? 1015. Okay, 1015. So now here, if you consider both the method, the which method is the most suitable method, the second method is most suitable method in this case, right? Now we'll apply the third technique, third method, right? And that is called a penalty method, right? Third method, that is called a penalty method. Okay, now method number 3, that is BAM. BAM. Vogel's approximation method. Come on, note down the problem. This is actually third method. Vogel's approximation method, or it is also called a penalty method. Chalo, come on, copy the problem. Note down the problem fast. Note down the problem. Solution. It is a penalty method, right? At the center of the notebook, you note down the table. At the center of the notebook, you note down the table. Come on. We have to calculate the penalties, row-wise penalty and column-wise penalties. While calculating the penalties, we have to take the difference among the two smallest elements. Right? Come on.
Done, sir.
Done,
Yeah.
sir.
All are getting or not? Other students?
Done, sir.
Okay, fine.
Done, sir.
Give the concentration, right? It is not that much difficult. Concentration, because based on theory, the question will be asked. So you have to answer in MCQ type questions, right? Okay. Now the penalties we have to work out. We have to work out the penalties, row penalties and column penalties, right? Say I will insert some columns, penalty 1, right? P1. Row wise penalty as well as column wise penalty. This is P1. Row wise and column wise penalty, P2. Right? Requirement. Insert P1, P2, P3, so on. We have to go on work out calculating the penalties, right? Okay, how to calculate the penalty, row wise and column wise, I will tell you. Okay, chalo. Now this is the cost matrix. As I said, from the cost matrix, we have to work out the penalties, right? Try to understand, everyone, please concentrate. Don't do those patience. Okay, from first row, right? From a first row, we have to work out the penalty 1, penalty 2, so on, right? Solution tape. Note down in your language. Calculate penalty by taking the difference of first two, by taking the difference of two smallest number first. Okay, from first row, which is the first smallest, come on, from first row, which is the first smallest,
10.
Again,
10.
I will remind you, 7 is not the part of the cost matrix, right? Again and again I'm repeating because you don't do the mistake, right? Because if they have given a small table and just ask MCQ to find out the penalty, so in a confusion here, 7 is there. So don't use 7. 7 is not the part of a cost matrix, right? 7 is a capacity. Requirement is also not a part of the cost matrix. So don't consider while calculating the penalties, only this cost matrix, right? Only this was cost matrix to be considered, right? Okay, now 10 is the first smallest. What is second smallest?
19.
19. Difference is how much? Difference is how much?
9.
9 is the first penalty. Similarly, for second row, what is the first smallest? Second row.
30.
Which is 30.
30.
What is the second smallest?
40.
40. Difference is how much? 10.
10.
10.
Third row. What is the first smallest? 8.
Eight.
What is the second smallest? 20. Difference is how much? 12.
12.
Right now, column wise, what is the first smallest? This
19.
much. Don't consider requirement. 19. What is the second smallest?
40.
40. The difference is how much?
21.
10.
21. Okay, here, what is the first smallest?
8.
8. What is the second smallest?
30.
30. There are two 30s, doesn't matter, right? So first smallest is 8. Okay, 8 minus 30 is how much?
22.
22. Right? Okay, now what is the first smallest?
40.
Second
40.
smallest?
50.
Difference is
50.
10.
difference is
10.
10. What is first smallest?
20.
10. Second smallest?
20.
20.
Difference is
10.
10.
is it over? Capacity
Yeah.
not required. Don't work out for capacity. Huh? Don't work out for capacity. Right? Okay. Now, don't work out for this capacity. Right? Okay. Now, if you look at the penalty, which is the highest penalty, row wise, column wise, both way, which is the highest penalty? 22 is the highest penalty. So the second solution tip, note down, right? Select the highest or maximum penalty from row and column. Select the highest penalty from row and column, right? Okay, what is the highest penalty from row and column here? Now you said me 22 is the highest. Am I right? 22 is highest. Same process are going to repeat, right? Again and again the same process are going to repeat. Okay, so I'll work out now. 22 is the highest penalty, right? So this 22 is the highest penalty belongs to the warehouse 2, that is second column, right? So here I'll mark this. This is the highest penalty. So just I'll make the color this. 22 is the highest penalty. Now this belongs to this particular row. So here in this particular row, right, we have to select the smallest element. We have to select the smallest element from the cost matrix. Which is the smallest element from the cost matrix?
8.
8 is the smallest element from the cost matrix. So not this 8. Again, don't consider requirement and capacity, right? Don't consider requirement and capacity. So this is the smallest element. 8. So here I have to allocate either requirement and capacity. But how much I should allocate now? Here I have to allocate 8, right? 8 requirement I can allocate. Okay, so I can allocate here 8 requirement. So this 8 is over. So this is completely over. This is completely over. So I will strike out this. And out of this 18, how much is allocated? 8 is allocated. So how much is remain? 10 is remain. So, right. So now this is, I will cross out. Now what is block? This particular completely column is block. Am I right? This particular column is completely block. So I will make the different color of this particular column, right? I'll make a different color of this particular column. Okay, ठीक है. We are not going to considering, so let it be unusable. Doesn't matter. Okay, fine. Now again, the same thing we have to repeat. Again, the same thing we have to repeat to calculate the penalty next time. But while next time calculating the penalty, don't consider this particular column. Right? W2, second column should not be considered. While calculating the penalty, this column should not be considered. Right? Okay, except this column. Work out the penalty. Come on. First
21.
smallest is 10.
10.
Second smallest is 19.
9.
Difference is 9. Here,
9.
first smallest is 40. Second smallest is, come on,
60.
60. Difference is how much? 20.
20.
Here, come on, first smallest is 20. Second smallest is 40.
40.
Difference is 20.
20.
Right. Now here, row wise, doesn't change. Right. First smallest is 19. Second smallest is 14. The difference is 21. Here, not required. It is already block. Now here,
Yes, sir.
this is how much? 40, 50, 10.
10.
This is also 10, 20, 10. Right. Again, the same logic we have to apply. Okay, select the maximum penalty from the row and column and allocate capacity or requirement whichever is less. Completed. Now the same process we have to repeat. What is the highest penalty now?
21.
21.
20. Where is 21? Huh? Where is 21? Sorry. Yeah. 21. Right. 21 is the highest penalty. Okay. From this 21 highest penalty, what is the lowest cost element from this particular row?
19.
19.
Here we have to allocate something. Something with how much I can allocate here?
5.
5 we can allocate. Right. 5, not more than this requirement. Whichever is less. Here it is 5 and here it is 7. Right. So 5 is allocated. So 5 is completely allocated. So this is block. And out of 7, how much is allocated? 5 is allocated. So how much is remaining? 2 is remaining. 2 is remaining. So that remaining 2 I will write here separately. Right. 2 is remaining. Okay. Now what is completely block? This one is completely block. Right. So again, I will make a different color for this particular. Only up to this I will make the color. Okay. Okay, fine. Right. Now, again, we have to repeat to calculate the penalties. Am I right? Again, we have to repeat
Yes,
to
sir.
calculate the penalties.
P3.
Right, P3. I will add some more penalties column. You go on adding, inserting column. Right. Okay, P3. Here, again, we have to P3. P3. Okay, chalo, come on. Now, merge cell. Okay, chalo. P3, we have to work out P3. Chalo. Here, how many elements are remaining? Only 2 elements, right? 10 and 50. 30. Chalo,
Sir-
fast. Here.
Sir, 40 आएगा ना?
No, sir. 40.
Sorry. 40. Okay, right. Because 50 minus 10. Then next here it.
Yes.
It
20.
is also.
20.
No, how come 20? Right. Barabar.
40
Right.
month.
Right. 40 and 60 is there, right? 20. So here, how much?
50.
50.
50, right. Now come on, P3 here. How much? This is block. This
Block.
is also block, right? Now
10.
50,
10.
40, 70, 10, right.
10.
This is also 10, right.
10.
What is the highest one?
50.
50.
50 is the highest one. What is the lowest one? There are only two elements. There are only two elements. So 20 is the
20.
lowest. 20 is the
20.
lowest,
20.
right? So how much I shall allocate here? This is
10.
10.
14, this is 14, and this is 10. So I can allocate 10. If I allocate 10, this is completely block. So this is completely block, and out of 14, 10 is already allocated. Am I right? Out of 14, 10 is
Yes.
already allocated. So how much is remain?
4.
4.
Fine. Now again we will go for calculating the penalty, right? P4. P4. Come on, in P4, difference. First smallest, second smallest, 40. Come on, here, difference. How much? 20. Come on, this is how much? Dash. Am I right? Yes or no?
Yes.
This is dash.
Yes.
Sorry. This is P4.
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 This is dash.
Dash.
Not required. This is not required. This is 10.
10.
This is how much? 10.
10.
50.
This,
50.
this is
50.
50. This is 50.
50.
This is 50. Good. Very good. This is the highest one. If you select the
50.
cost element from this, so which is smallest? This one. So here I can allocate. How much I can allocate now?
2.
2.
So this is 2 is remaining, and this is 4 is remaining. So how much? 2 I can allocate. 2 I can allocate. So this 2 is already over, means completely block. This is completely blocked, and out of 4, how much? Out of 4,
2.
2 remaining.
2 is
Two is
remaining.
remaining.
2 is remaining. Fine. So this is, I will cross out this. And here two is remaining. Okay, fine. Okay, chalo. Now what is block? This is completely block. Am I right? This is block. So I will make a different color to this. Okay, chalo. Again we have to work out penalties, right? Again we have to work out different penalty, row wise and column wise. Tell me the penalty. P5. Penalty 5. Come on, here also P5. Come on, tell me. Now this is completely block.
Block.
Yes. Dash.
Here, how much?
20. 20.
Oh,
20.
20.
Right. This is block, right?
Block.
This is block. This is block. This is difference. There is no
40.
difference. There is no two elements. Single element is there as it is. We have to carry. Understand?
4. Yes, sir.
60. There is no two. There are no two elements, so there is no question of difference. So whatever element is remaining, you should carry out that element. Okay. Calculated. Got it? Now. Next. Come on. What is highest? 60 is highest.
60.
But in this 60, only one element is remain. Am I right?
Yes.
Only one element is remain. So here I should allocate. How much I should allocate? This is 2 and
2.
this is 9. So 2 I can allocate. And out of 9, the 2 is already allocated. So how much is remaining? 7 is
7.
7 is remaining. right? Okay, 7 is remaining. Now, no need to calculate the penalty. How many elements are remain? Only one element is remain here. Am I right? If you take the penalty, here you will get a penalty 40. If you take this penalty, here you will take a penalty how much? 40. So only one element is remaining. So here I should allocate how much? Come on.
7.
7.
Capacity is 7, requirement is also 7. Both are equal, both are matching. It means that our answer is correct and it is 7. Now you note down the answer. Now you note down the answer, that is total transportation cost. Total transportation cost is equal to, come on, 19 multiplies how much? 5 plus
8 multiplied.
8 multiplies 8. 8 multiplies 8 plus the
40
next 40 multiplies 7 multiplies 7 plus the next 10 multiplies
2.
10 multiplies 2 plus 60 multiplies 2 plus 20 multiplies 10 over.
Yes, sir.
Yes, work out the cost. Work out the cost. Work out the cost. What is the total?
Sir, 779.
This is 779. Right? All are with me? All are agree with this answer? Yes. Count has come down. 3 to 4 students they left. I'll be taking attendance at 8. You don't worry. Okay. Huh. Those who have lose the patience, they might left the meeting. Okay, don't worry. Any other answer, or all are agree with this?
Right
Come on.
answer.
Yes, sir,
7.
correct.
Right. Okay, now just within a 1 second we'll compare the answers. Right, so last method is 779, second last method is 814, and the first method was 1015. Which is the lowest answer? Which is the lowest transportation cost? Last method. It means it proves that the Vogel's approximation method gives the better solution. I'm not saying that again 100% solution or the best of best solution. Vogel's approximation method, it gives the better solution, right? It gives the better solution. So that is why it is called an optimal solution. Now to test the optimality, just I will write down here, note down the formula. In case of MCQ question, to test the optimality, m plus n minus 1 is equal to number of allocation. This formula is very important. Whether we can modify the solution, whether we can improve the solution, right? If we can improve the solution, then this condition must be satisfied. To test the optimality, the following condition must be satisfied. Following condition must be satisfied. Yes, what do you want? Regarding job, only 5 minutes, please sit you 5 minutes. Okay, to test the optimality, the following condition must be satisfied, right? Okay, what is condition? M plus n minus 1 is equal to number of allocations. Very important question in MCQ question, right? Okay, what is m plus n minus 1? So m plus n minus 1 is equal to number of allocations. So m means what? Number of rows. N means what? Number of columns. minus 1 is equal to number of allocations. Now, if you take this example, how many rows are there? 1, 2, 3. 3 rows are there. So 3 plus how many columns are there? 4 columns
4.
are there, right? 4 columns are there. Minus 1 is equal to how many number of allocations are there? You count the number of allocations. This is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Am I right?
Yes, sir.
Yes.
Okay. What is 6? Am I right? Once again, I will repeat the number of allocations. 19 5s are allocated. 1, this is 2, this is 3, this is 4, this is 5, this is 6. 6 allocations are there. So 6 allocations are there. So 3 plus 4 is how much? 7. 7 minus 1 is how much? 6. 6 is equal to, right? 6 is equal to 6 is equal to 6. Is it condition is satisfied? Is it
Yes,
condition
sir.
is satisfied? Yes, yes, yes.
Yes, sir.
Yes.
Right. So in MCQ question papers, to test the optimality, what will be the conditions? They may give m plus n minus 1 number of allocations, or otherwise direct they will give the values, different values we have to match. If it is match number of allocation, then the meaning of this is there is some more scope to improve the solution. Again, we can improve the solution. Best of best solution we can find out, right? The whatever answer we received by using this method, that is 779, yes, it can be improved. The better answer can be received. Better answer can be available. That is clear by using this optimality test, right? Now, yes, if it is better answer, then again we have to modify the existing problem by applying the two formulas. Note down the formulas. Ui plus Vj minus Cij, right? Ui, first formula is, in the MCQs they may use the Ui plus Vj minus Cij. Ui plus Vj minus Cij means C of ith and jth allocation, and second formula is used for allocated cells. It is right for allocated cells. It is called for allocated cells. Say sometimes in the MCQ question paper they may ask what is the formula to calculate the modified solution for allocated cells. So the allocated cells, the formula is Ui plus Vj minus Cij, and for non-allocated cells, formula is Cij is equal to Ui plus Vj minus Cij minus Ui plus Vj. Non-allocated is Cij minus Ui plus Vj. Just I will test, I will check the formula, both formulas. I will send you this methods, this optimality test. Everything is given detail. So these are the two formulas. This detailing is there. You don't worry. I will send you this Word file. Just and detailed steps also given. If you read out this, you'll understand. So these are the two formulas for allocated cell and for non-allocated cells. All right. To test the optimality, test, right? So these are the two formulas. Finish. Cij is equal to Ui plus Vj for allocated cells, and for non-allocated cell Dij is equal to Cij minus Ui plus Vj. This is the formula. Keep in mind. So this is first formula m plus n minus 1 for testing the optimality precondition. Second formula is Cij is equal to Ui plus Vj for calculating the allocated cell value, and the third formula is Dij is equal to Cij minus Ui plus Vj for non-allocated cell values, right? So this is in short the short revision of an assignment problem. Depend upon the situations, again we'll come back to discuss the problem, or otherwise I have some MCQ type of sample questions. So I will mail you, I will send you on WhatsApp and your mail ID. You don't worry. Meanwhile, today I will share this Word file. In this Word file, the theory as well as the problem are available. In future, for future reference, you can refer this Word file. If you practice this Word file, this is more than enough, right? This is more than enough. Very systematic. We have spent a lot of time while teaching only, right? This Word file as well as I have got a video lectures also I will send you. By listening the videos lectures, you can clarify your doubts. And from tomorrow, I'll be starting the new topic, right? Okay. Any doubt?
No, sir.
No, sir.
No, sir.
Okay.
No, sir.
Chalo.
No, sir. No,
So next lecture, don't miss the next lectures. Next lecture will start either queuing theory or a game theory. Anyone will decide. ठीक है, चलो, all the best.
Thank you, sir.
Thank you, sir.
Okay, welcome.
Thank you,
Thank you,
sir.
sir.
Okay,
Thank you, sir.
Thank you. Okay, I'll be leaving. I will take your attendance and I'll leave the meeting.
Okay.
These sessions I have not recorded because already recorded sessions are there, so no need to record again and again.
Please share the link for video lectures.
You want video lectures link also?
Yes, sir.
Okay, I'll share you. I'll share you because instead of on WhatsApp, I will share to your mail ID. Your mail IDs are working, na? You are using your mail IDs?
Yes, sir.
No, sir, my mail ID is
So,
I will share to on mail IDs because the video link is having more capacity. So better I will share on mail IDs.
my mail ID is not for college.
College mail ID? College mail ID is with you?
No,
Are
sir,
you
it is not.
Yes, sir.
are you using college mail IDs?
no, sir.
Why? Because we are sending
Yes.
communication to your college mail IDs. Huh? Everyone has got a college mail ID.
TRM
Yes, sir.
and all.
सभी को
Yes,
मिला है
sir.
ना?
Yes, sir.
Yes,
हाँ.
sir.
Yes,
Yes,
sir.
sir.
Any
Yes, sir.
problem? Anyone is having problem with college mail ID?
No, sir.
Because
Yes, sir. No
Yes,
problem.
Yes, sir,
whatever the problem you bring to the notice of your course coordinator, because we are sharing the materials, we are sending the placement announcements, notifications to your official mail IDs. So you take care. You
Yes,
keep on
sir.
operating. Keep on operating. WhatsApp as well as mail ID, both we are using, right? But WhatsApp has got some limitations, so we will share it on your mail IDs. Chalo, okay, bye. Next lecture is there, huh?
Bye, sir.
Okay, bye.